Hello guys, welcome back. My name is Andrei. In this video I'll talk about Skipper, our MLOps solution that helps to run different services in a simple and efficient way. Skipper was implemented a while ago and we're using it already to run our internal ML operations and it's open source. I'll put a link below the video. And other people are also using it from the community. Time to time I get different questions about it. And recently one of the users asked a question how it will be possible to debug the service easier, because by default everything runs through Docker. All the infrastructure started with Docker compose command. Then all the blocks run in Docker containers. You can get logs from the containers, but it's how to improve the efficiency of the programming, to have an option to change the code of the certain service and then basically test the same flow with other services that you're not changing now, other services running in the containers. So I'll show you how you can debug this kind of functionality and how you could enable the approach where you would be able to run containers and a certain container that you want to change, then you could stop it and change the code locally on the computer and test your changes without stopping other containers, so without interfering with the flow. Okay, so let's start. So here is the diagram, which from the high level explains how Skipper is structured. There are different set of services. There's an engine block, then there's a communication, and microservices part represents specific services that actually implement your use cases. It could be data training, then maybe some data processing, and so on and so on, different kind of services that you may implement in your infrastructure. So what we'll do today, what I'll show is, I'll show how you could stop, for example, and change locally or debug locally, for example, salary block, and also maybe training block. So all the rest will run inside the Docker infrastructure, and training and salary will adjust locally and see how the changes can be tested in a very simple way. Okay, so just to start, so everything, let's see. Yeah, so all the infrastructure started with this one command, docker compose up -build d, and this starts it builds all the images, starts all the containers up and running, and like RabbitMQ, all the communication is enabled out of the box, so you don't need to do anything. All the sample services started, like data, training service, and sample mobile net services started as well. And maybe in a future video I'll explain how you could, for example, remove a sample service like MobileNet, and how you could add a new service. So you would this would help you to work with Skipper probably, and would give you ideas how you could adjust it easier. But today we're focusing on this debugging thing. So okay, we have everything is up and running, let's say, and then what we can do, we can go to, for example, Docker desktop dashboard, and what we can see here, once everything is started, you can go usually into the Katana Skipper group, and here you got all the containers that are running currently. And what I did before the video, I stopped Skipper API salary, then I stopped training service and Skipper API. All other services are running, and the log is being printed, and all the other services are up and operational. So I stopped those ones, and then I went to the PyCharm, and I loaded the code for the API project here. And what I'm doing is here under the terminal from the PyCharm, I started fast API endpoint that listens for the request to the API. And then there's another process, Celery process, which allows to execute asynchronous requests through the API. And then through Celery, you can track if task is completed. If it's not yet completed, to get information about the task. And it helps to run asynchronous tasks. Okay, so now, and this is one service, and another one, training. It also runs. It stopped in Docker Compose in a Docker environment. I loaded the code locally for the PyCharm and started the process here. So it listens for the requests. And now if I go to, I go back to API and let's say clean it up here, and then I go to the browser and I initiate new model training. So for that, I just click execute here, and then I go back to PyCharm, and we wait a few seconds, and we see that task is completed. So in this case, it's just a sample training service. It runs really fast for demonstration purposes. And if you go to the training service, I see some information is printed over here. So now, let's say I want to change something, and I want to show you how it works. So I could say that print. And let's say we can say the training service called like that. Okay, that makes sense. Now what we need to do is we need to restart the service so that this change will be available. Okay, it started, and now we can clean the log here, and we go to API, and let's also do some change over here. Let's print maybe just this variable, response JSON, so two things will be printed. Okay, and again here we stop and start again the process locally, so it's really fast. Clean it up, and then I go again to model training execution. I execute and go back to this window, and now we wait a few seconds. Okay, so now we get back this information over here that it's this thing is printed, and basically you see that now the change was executed. And if you go back to the training service, go here, we can see this print training service called. It's printed from here, so the change was applied as expected. Okay, so to summarize, it makes it much simpler for the development when you have all the processes running, all the infrastructure in Docker. Then you stop some of the services that you want to change, and you open the code for the service in your local development environment, like a PyCharm or Visual Studio, and then you start that specific service locally with Python main, for example, or with the Celery, if it's a Celery process, and then you change it locally and restart the process and execute the entire flow, and the message will be traveled through. It will go through all the services as in the same way as it would run as a single infrastructure in Docker container. So that makes it easier for the developer. So thanks for watching, and see you next time. Bye.